everyone. So quick video over linear and absolute value equations and functions, because this should be pretty much review as we move into our functions unit in general. And so just going back over your linear functions and looking at how to write an equation for a line and then how to graph that as well. So remember, to write an equation for a line, you need the slope, which is your rise over your run, and we denote it as m. And you need a point. That is on the line. So with those two things, you can write an equation for a line. So there's three formats for your line. Point slope form is y minus y1 equals m times x minus x1, where remember your y and your x stay y and x the whole time. And the other values are things that you plug in. And so we see over here, for example, we have the 0.13 and m is 2. So this point then is your x1, y1, and you just plug that in. And so the subtext on it, the ones are just telling you it's the first point that you have given on this line. Okay, so y minus 3, watch your signs here. If it's a negative, it turns to plus. M is 2, and then x minus 1. And you can actually just stop here. This is the equation for the line if they're asking for it in point slope form. And it's a totally valid format, just like slope intercept form, which is next, being y equals mx plus b, where we have the y-intercept and m is once again your slope. So you still have a point and a slope on this line, right? Where up here you have a different point other than 0, whatever. It's still the same idea. We're starting at this point and we're going to take our rise over our run to get where we're supposed to be. So to convert point slope form to slope intercept form, we just need to distribute, that's this example here, distribute your 2 through. So you get y minus 3 equals 2x minus 2. So y equals 2x plus 1. And so your y-intercept for this example is the point 0, 1. All right, it is still a point on your graph, and your m is once again 2. And so you can see we always have that point, we always have the slope. Okay. Standard form is the only one where you can't like clearly see what those things are. Standard form is ax plus by equals c, where a, b, and c are integers. So there's a word from Unit 1. Keeping in mind that often, at least in textbooks, and I'm not this picky, a cannot be negative. So you'll see, at least on standardized tests and on worksheets, often they'll make that positive. A and B do not both equal 0, or it's not a line, right? And so for this one, to get it in standard form, we're just going to move our x to the other side. So negative 2x plus y equals 1. Again, often in a textbook, you'll see them flip all those signs so that you have 2x minus y equals negative 1. I don't care which one you use. And they just like to make the lead coefficient positive. And then just practice writing an equation for a line. So let's go ahead and write these in all three formats. We have y minus negative, so plus 1, equals 6 times x minus negative, or plus 3. So there's point slope form. Converting that, we have y plus 1 equals 6x plus 18. So y equals 6x plus 17. And then converting it once again, we get negative 6x plus y equals 17. So there's your three forms for this line. Okay, go ahead and pause and try 5. Okay, quick reminder, with 5 you have to start by finding the slope, and so you're going to plug things into your slope formula. So y1 or y2 minus y1 over x2 minus x1. It doesn't really matter which one's 1 and which one's 2, so long as like the 6 and the 5 are aligned vertically and the 3 and the 2 are aligned vertically. Okay, go ahead and find your slope and then finish that problem out. Okay, so you can see here, if you're using point slope form, you can have either this or this. They're both valid answers. Converting that into slope intercept form is where everyone will have the same answer, and that will be this. And so some work with fractions and common denominators when it comes to this back half here. Sorry, I just made that really sloppy. All right. Okay, and then just a general reminder on this next one that we're talking parallel, and parallel lines have the same slope. So it's really no different than number 5. We're going to start by finding that slope. And so it's parallel to the line through these 2 points, which means it has the same slope. And so we do 6 minus 2 over negative 2 minus 6. So we get negative 1/2. And then we can plug that in to our equation. So we're going to use, once we've used those 2 points, we're done. And we're going to use the one that's talking about line L, so y plus 4 is equal to negative 1/2 x minus 2. And again, to get that into slope intercept form, you would distribute and then subtract the 4. All right, perpendicular means that the slopes are opposite reciprocals. All right, so we need to identify the slope of this line first. So if 2y plus 5 minus 3x equals 0, we want to get this into y equals mx plus b so that we can identify what the m is, and then we can find the slope that's perpendicular to it. All right, so multi-steps here, but we're essentially going to solve for y. The easiest way for this one to do that is actually to move the y, since everything else is on this side also. So, and I'm going to flip these around so that I have my x in front. So negative 3x plus 5, don't lose your negative, is equal to negative 2y, and then divide off your negative 2. And it doesn't matter that I've got a bunch of fractions here. My slope is still right here, is 3 over 2. So the slope that's perpendicular to that, opposite reciprocal, so positive becomes negative, and I flip that over. So this is the slope that I'm actually going to use. All right, and it's going through 2, 7. So this is my x1 and my y1. And so I just plug in from there. So y minus 7 equals negative 2/3 times x minus 2. And again, I distribute, add the 7 over if I want that in slope-intercept form. Actually, let's skip ahead here for a second and show you that. Okay, so this would be your slope-intercept form, and I skipped to that because I want to show you how to get that into then standard form, because remember a, b, and c have to be integers. So we can move the x to the right side. Now it's at least in the right order, but we have some non-integers here. And so to get this into standard form, I need to actually multiply through by that denominator to get rid of the fraction. So like we did in Unit 1, clear your fractions out. so that you get 2x plus 3y equals 25, and this would then be standard form. Okay, well, like I said, you need a point and a slope to write an equation in slope-intercept form. So the best point to have is your y-intercept. This is the point 0, 2. So this is your b. And then you can just count your rise over run if you're doing it on a graph. So we're going down 2 over 1, 2, 3, 4. So negative 2 over 4, which then reduces. And go ahead and write your equation. Okay, so y equals negative 1/2 x plus 2. All right, we're writing this equation into slope-intercept form so that we can identify the slope and the y-intercept. Get it into y equals mx plus b. Go ahead and try that now. Okay, again, for this one, it was easier to move the 2y to the other side and leave everything else. I just flipped the x and the 5 around so that it would be in the right order. My m here is negative 1/2. My b, or my y-intercept, is at 0 and 5 halves, or 2 and 1/2 if you want to convert that to a mixed number. I pretty much leave things improper. All right, moving into graphing. So just remember that you need a point and a slope. You can start by graphing that point and then follow rise over run. If it is a whole number, just put it over 1. But yeah, just remember rise over run. Negative lines should fall. Positive lines should rise. Undefined lines are vertical, and horizontal lines are 0. Okay, so you have your little slope man there. We're going to graph y-intercept here is at negative 1. Slope is negative 4. So you can go up 4, left 1, or you can go down 4 over 1, as long as you move in the negative direction at least just one time, and draw your line as straight as possible. It's hard to draw straight lines with your stylus. Okay, so go ahead and graph the next. Okay, so this one is about halfway, or it is halfway between these two tick marks. I want you to put at least 3 points on all of your graphs if they'll fit, and make sure to show your scale by your tick marks. So if, like, actually put tick marks, don't just do a rough sketch, okay? If you're counting by any more than 1, indicate that as well by putting a number, okay? You can also graph by making a chart if you would like to. So you have your X, Y. Yeah, sorry about that. I put X. So you just are really picking points. So you want them to be reasonable. I'm not going to put 50 in for X, though I could and get a value and it would be fine. All right, so I'm going to pick relatively easy numbers to plug in. So like I'm going to plug in 0. So I do 2 times 0 minus y equals 3. If I solve that out, then I get negative 3. So I have the point then 0, negative 3. All right, well, that's my y-intercept. So that's nice to know. Or I can plug in, let me plug in a negative number. So let's just do, again, negative 1 for ease of what's easy to plug in. So I have 2 times negative 1 minus y equals 3. Well, that's negative 2, so I'm going to add that over. That's 5. Then I'm going to make it negative, so negative 5. Negative 1, negative 5. So you have your input, your output, that creates your coordinate. So negative 1 is at negative 5. Well, now I can see my slope, and I could just theoretically count this from there. But I'm not going to, again, I'm not going to go over here and plug in negative 6 because that's going to go off my graph. I'm probably not even going to plug in positive 6 because at this rate, that might even be off my graph, right? And so I'm going to plug in 1. And again, these are completely random values. They're not even in order. And it doesn't matter because you always will have an input and an output. So that's 2, that's 1, that makes that -1. So 1, -1. All right. And so this idea that you have to use specific numbers is just not accurate. Okay. I don't even necessarily have to go through my y-axis. I could have started way over here at 2 and done 2, 3, and 4, right? Okay. So you can also graph by your intercepts, especially when it's in standard form like that. So to find the x-intercept of the graph, plug 0 in for the y. To find the y-intercept for the graph, plug 0 in for x. And so if we plug 0 in for y here, we get 13 divided by 2, excuse me, comma 0. And then if we plug 0 in for the x, we get 0, comma -13 over 9. Those are icky numbers to graph, but those are the intercepts. So this is why we wouldn't always necessarily graph by the intercepts, because often you get fractions. But sometimes it works out nicely where both of your coefficients divide evenly into that constant. And so, like for example, if I plug a 0 in for x here, then I get 12 over 3, which is 4. If I plug 0 in for y, I get 12 over 2, which is 6. Okay, but either way, you have 2 points, not just one. I would graph 0, 4. Oops, I did that backwards. 0, 4, and then 6, 0. And that would be my line, which has a negative slope, which makes sense because if I solved for y, I would get a -2 before I divide. All right, and then the last thing I want to remind you of is absolute values. Remember that absolute values is essentially just graphing your positive case and your negative case in the same graph. And so we're saying that y is equal to x and y is equal to -x. But they have restrictions. So y is equal to x, or f of x is equal to x, when x is greater than 0, or equal to, really. All right. And then y is equal to -x when x is less than or equal to 0. And since I used equal to, I'm going to take that part off. All right. Because these are your negative x values. Would go in here to make this true, because y will always be positive. And so if x is less than 0, and I should have specified that, then those are negative, and then this negative will make those positive, which sounds confusing, but here's what I mean. So absolute values always graph a V shape, right? And so if my x value is greater than or equal to 0, that means that the absolute value of x, when I'm looking at just these values, I have 0, I have 2, I have 3, and all of those end up this same value. So the y and the x value are the same. All right, so think about how these are all the same. So I have that point 0, 0, 1, 1, 2, 2, 3, 3, and so on and so forth. All right, this goes up like this. For the flip side of that, if I'm graphing -x, but all my values have to be less than 0, that means I'm doing negative, -1, negative, -2, negative, -3. And so because I have 2 negatives, that y value still ends up equaling x. And so here is 1, here is 2, here is 3. So these two sides end up the same. So x -1 ends up 1. -2 ends up 2. -3 ends up 3. And so I get this V-shaped graph, which is called a piecewise function, really, which we'll talk about tomorrow, for that. All right, so every absolute value is a V. When you then add in these, and we'll do just a lesson on transformations, it's going to shift your graph. And so we're going to have, this is what's called the parent function. We're going to have the same v, but we're going to go right 6 and up 4. All right, and it might just be easier starting out if you don't want to memorize transformations to make a t-chart. And so I'm going to start with, well, 6 gives me 0 plus 4 is 4. So 6, 4. And then maybe I do 5. Well, 5 gives me -1. The absolute value of -1 is 1 plus 4 is 5. Okay, so 5, 5. And then maybe I do 4. Well, again, 4 minus 6 is -2. The absolute value of that is 2 plus 4 is 6. And so I graph 4, 6. Okay, well, I'm not just going to draw my line. Instead, I haven't gotten that V shape yet. I need that V shape. So I need to go on the other side of my 6. Let's try 7. Well, 7 minus 6 is 1, plus 4 is 5. As soon as you see that reflection, you see that Y value repeat, then you know you've got your V shape. And so I can graph 7, 5. And now I have my V shape, and I'm done. Okay, it must graph a V. All right. And that's it for that. So let me know if you have any questions. Again, this should be review, and have a good day.